Okay, so we're going to do probably a few examples that you guys have picked right out of the worksheets. And the first one, page 35, question 8. And on page 35, question 8, the question asks, how many moles are in 2.47 times 10 to the 22 formula units of magnesium hydroxide? So the first thing you do in all these questions is look for the number. And the number given was 2.47 times 10 to the power of 22. And see what units were beside the number. The units actually guide us in solving this. The units they gave us was formula units. It's like saying a molecule, but proper name for it if it's ionic. So it's important to have the number and the units. And then we're going to draw a big long line, and we're going to cut that off. Now, whatever unit was given here, we're going to always write that unit down and to the right. So I'm going to write the units, formula units down there. That's going to allow it to be canceled. Okay? So whatever units goes here, I immediately write down there. And what I'm comparing it to every time, what I'm changing it into is moles. So I'm going to write the word moles here. Okay? Now, when we have number top and bottom like this 1 mole, or moles to formula units, moles to molecules, moles to volume, the number that always goes beside the word mole is the number 1. And then I need the truth. Well, formula units are something I'd count. I could count formula units or molecules or atoms. And how many are in a mole? This is Avogadro's number, 6.02 times 10 to the power of 23. So 1 mole contains 6.02 times 10 to the power of 23 formula units. So formula units on the top will cancel formula units on the bottom, and the only words that I haven't crossed out is moles. So now my answer, I know, will come out in the form of moles. When numbers are top and bottom, the math function that you hit on your calculators is divide. So I want you guys on your calculators, and I'm going to write down the calculator presses here. You're going to write 2.47, and then I want you to find that EXP or E button 22. This tells us that 2.47 times 10 to the 22 is one number, not a series of math functions, okay? Then we hit divide because this number is on the bottom, and we end on 6.02, and again hit that EXP or EE button, 23, and then we hit equals. Record again. So this will give us an answer of 0.04 moles. I know the answer is moles because it's the only one that I didn't cancel. So also on page 35, question 10. In this case, we are given the number of 0.675 grams. So we're going to 0.675 grams, and it's grams of iron sulfide. And it's important to know what I'm measuring because grams depends on the substance that you're measuring. And we're asked to find molecules. Now, we can't go directly from grams to molecules. We have to think back to that Y diagram. Again, so in the Y diagram, we've got moles in the middle, and that is the one thing that links grams and liters and the number of particles together is always the word moles. So we are at grams. We are right here. And the question wants us to get to how many molecules. It wants us to get here. We're going to start with grams. You can see that I first have to change it to moles and then have to change it to the number of particles. And the fact that I've used 3 circles in this picture tells me that my factor label line, as I draw it, will have 3 sections. So this little Y diagram actually sort of labels it out and tells us how to solve it. I've used 1, 2, 3 circles. My label has 1, 2, 3 sections. The first one is what you know, and in this case I knew grams. Now remember what I told you, whatever unit is up in the starting point goes down and to the right. So I'm going to write the words grams there. And you can see that the first thing I'm changing it into is moles. So I'm going to write the word moles here. And what number always goes beside the word moles? 1. Yes. And what is the relationship between moles and grams? Well, the relationship between moles and grams is molar mass. So you need to go to your periodic table. And you need to add up, from the formula iron sulfide, you need to add 1 iron plus 1 sulfur, because that's what's in that formula. So on a periodic table, whichever one you can find, you can find out that iron, right below it, weighs 55.85 grams. And sulfur, when you look it up on the periodic table, weighs 32.07 grams. So when you add them up, you're going to end up with 87.92 grams. So what we see is that every 1 mole of iron sulfide is 87.92 grams. So anytime we have moles and grams, what you need to do is go to your periodic table, find the molar mass. Well, let's do some canceling. I can see the grams on the top canceled the grams on the bottom. So grams are gone. I'm at moles. I'm still not done because the question said get to the number of particles. So again, I need to get rid of the word moles. And whatever number's on the top goes down here so I can cancel it. So I write the word moles there. I'm trying to find the number of molecules of iron sulfide. I want to find how many particles there are. Again, always the number beside the word moles is 1, because this is always 1 mole equals. And what is that magic number that connects moles to the number of particles? Yeah, 6.02 times 10 to the 23rd is correct. So moles will be gone. Now the units I have are molecules, and that's actually what I wanted. So the math functions that go along with this is numbers on the top of the line times numbers on the bottom of the line, you divide. And the order is irrelevant. So in your calculator, you'll go 0.675, and then this number's on the bottom, so you say divide by 87.92. And then the next number's on the top of the line, so you say times by, and you enter 6.02x 23. Make sure you use that EXP button. So we'll get 4.62 times 10 to the power of 21 molecules. And I know I've done this right because grams is canceled, moles is canceled, and the only units I had left were molecules. All right, question 9 on the same page says, what is the mass of 6.49 times 10 to the 26 formula units? Look for the number, write it down. So the number is 6.49 times 10 to the power of 26. And I have to write this down with the units that it is, formula units. So I am right here. I'm at this point, and it says to find mass. Well, which point on this Y diagram is mass? The answer is grams. We can see that I'm starting with the number of particles, formula units. I'm going to first change it to moles, and then I can get to mass in grams. So again, there are 3 circles here in this picture that are used. My factor label line is going to have 3 columns. The little picture is going to tell us exactly how to get there. Okay? So, the first unit I have is formula units. Where do I write it? At the bottom. So I'm going to move over and write this at the bottom. What is the first thing that I'm changing formula units into? Moles. I write that on top. What number always goes beside the word mole? 1. And what is the linking number between moles and counting? 6.02 times 10 to the 23rd. That's Avogadro's number, and one we're just going to have to learn. Okay. So far, I can see these formula units are canceled, and I'm at moles. I'm right here. I'm still not done. So, this number now, the word moles, is going to go where? On the bottom, so it cancels. Next thing I'm trying to find is grams. So grams goes on the top. What number always goes beside the word moles? 1. In order to find grams, I need to do a molar mass. And we're dealing with magnesium hydroxide. So magnesium hydroxide has this formula. This means I need 1 magnesium times its mass, plus 2 of the oxygens times their masses, plus 2 of the hydrogens times their masses. So when we add these all together, we get a total mass of 58.33 grams for every 1 mole. We know we have 1 mole then would weigh 58.33 grams. That's our molar mass. So now moles is canceled, and I'm left with grams. That's where I wanted to get. So again, multiply numbers if you see them on the top of the line. Grab your calculators. Divide numbers on the bottom. And for these numbers in scientific notation, use that EXP button on your calculator, or EE, or whatever version yours is, so that the calculator knows that you're just getting one number, not a whole series of math expressions to do. So when we multiply across the top and divide across the bottom, you get 6.29 times 10 to the 4th grams. Now, this is a positive value here on the exponent. So that means that when we take that number 6.29, you can move your decimal point over 4 spots and then fill in zeros. And so you get 62,900 grams, okay, or 62.9 kilograms. So I don't care how you express it, I'm going to recognize that. It depends on whether or not your calculator is set to scientific notation or just expanded. But it means the same thing.